A warm greetings from Dr. Muthuselvi. I am working as professor in the Department of IT, Kamaraj College of Engineering. So, we all know the importance of operating system. The main function of an operating system is memory management, where we have to deal with pages. So, now we are going to discuss on page replacement. See, in memory, we are going to have many pages. So, at one particular time, the memory is filled with pages and a new page is to be placed into the memory, and there is no place for that particular new page. Then what should be done? That is the question. So, here we have the page replacement algorithms which are going to be very useful. So, they will decide which page should be replaced. And we know there are pages that is it is due to the kernel, IO buffers and by process pages. So many pages are there. So, here there is an issue. How much to allocate to each? So, if there is an IO request, how much space should be allocated? So, if there is a request from the kernel, how much page should be allocated to that? So, that is an issue. So, now the next one, it is page replacement. So, which page is to be replaced? So, that is to be decided. And if I am using one particular algorithm for page replacement, then the algorithm what it should do when a page is not available. So, whether the algorithm will terminate or it will swap out one particular page or it will go for replacing the page. So, these are the questions we have. So, we have to find the solution for that. Then the performance of the algorithm, we have to think about that also. So, if there is a minimum number of page fault, then I will say the performance of the algorithm is good. So, in general, that is the over allocation of memory that can be prevented by using the page replacement algorithm. And we have a bit called modify or dirty bit, so that the overhead of page transfers that can be reduced. So, usually page replacement, it is a separation between the logical memory and the physical memory. So, all these points tell us the importance of page replacement in an operating system. So, basically a free frame actually it should be found out, so that a new page that can be placed. So, if there is no free frame, so we have to remove one particular page or we have to replace it. See, these are the 4 important steps. See, here we have a page table, then we have the physical memory, and here we have the backup store. So, in step number 1 actually, one particular page it is to be replaced and we can call that as a victim. So, in the page table we have the particular page with label F, and that is marked as valid because still that particular page is available in the physical memory. So, when a new page is to be placed in the physical memory, and here what happens, victim, that is the F page, that is to be swapped out. So, that is the first step. Then in the second step, the validity of that particular page, now it is marked as invalid. So, previously it is marked as valid. So, now after swapping out, it is marked as V. That is the second step. Then the third step, the new page will be moved to this particular location in the physical memory. So, that is the third step. And in the fourth step, the page table will be reset. So, the entry for the new page will be entered into the page table. So, when page replacement is done, these are the steps processed by the operating system. So, when we are using the page replacement algorithm, we would like to have the lowest page fault rate. So, that is very important. So, what we can do, simply we can take a string of memory references and that can be applied on the page replacement algorithms. We can find the number of page faults and we can evaluate the page replacement algorithm. So, in page replacement, we have three algorithms: FIFO, optimal and LRU, that is least recently used. So, now we are going to see one by one. So, here we are going to take an example, that is a page reference string 701230430323. So, these are the pages, that is the reference string. So, here number of page frames, it is equal to 4. Let us go to the first algorithm, FIFO, first in first out. So, here what is the rule? Replace the oldest page in memory. So, whatever the page which has been residing in the memory for a long time, that can be replaced. So, that is the rule for the first in first out algorithm. So, for the given string, we are going to find out. So, at step number 1, that is the first reference, that is 7. So, that is put into frame 1. So, now frame 2, frame 3, frame 4, they do not have anything. So, now it is going to be called as a page fault because 7 is not available in the memory. Then the next one, it is 0. So, already in frame 1 I have 7. So, I go to the next one, it is frame 2. So, there I have the page 0. So, it is also going to be a page fault because 0 is not also available. The next one 1. So, I have to go to frame number 3. It is also going to be a page fault. Then come to the next one, it is 0. So, here already I have 7. So, 0 is already available. It is already available in the memory. So, now it is called as a hit. It is not going to be a page fault. The data, the page is available there. Then the next, in the next page in the reference string, it is 3. So, I do not have 3. So, I have 7, 0, 1, 2. So, 3 is not there. So, now I have to go for page replacement. So, I have to identify which page I have to replace. So, according to the rule, we have to find out the oldest page in the memory. So, let us see that. So, 7 is the oldest page because that is the page which has been put into the memory long back. So, I have to replace 7 with 3. So, now in the memory I have 3, 0, 1, 2. So, here it is a page fault because the page 3 is not available there, and which I am going to replace 7. Page number 7 I am going to replace. Then the next in the next page in the reference string, it is 0. So, I am looking here, yes, 0 is there. So, now it is not a page fault, it is a hit. So, I am writing that as H. Then come to the next one, it is 4. So, look at here 3, 0, 1, 2. I do not have 4 there. So, I have to go for a replacement. Then I have to look for the memory which is residing longer in the memory. So, after 7 now I have 0 which is the oldest page in the memory. So, I have to replace 0. So, now 4 will be placed in that location. Okay. So, now it is a page fault. So, 0 is now replaced. Then I have 2, yes, 2 is available, it is a hit. Then I have 3, yes, 3 is also there, again it is a hit. Then the next one, it is 0, again it is going to be a page fault because I do not have 0. So, now I have to look for the oldest page. So, 1 is the oldest page and that is replaced by 0. So, it is again a page fault. And if I look at the string there, so I have 3, 2, 3. So, 3 is there, it is a hit. 2 is there, it is a hit. Again 3 is there, it is a hit. So, if I count the number of page fault, 1, 2, 3, 4, 5, 6, 7. So, totally I have 7 page fault. So, this is how first in first out algorithm works. And this is optimal page replacement algorithm. So, here the pages will be replaced, the pages which would not be used for the longest duration time in the future. So, we have to look into that. Based on that, the page will be replaced. So, let us look at the table. We start with 7. So, as we have discussed previously, 7, 0, 1, 2. So, these are already, they are not available. So, all these are put into the corresponding frames, that is frame number 1, 2, 3, 4 and page fault. All these are page fault. Then when I come to the 0, then I have to replace one particular page. So, I have to find out. So, here actually 0 is available. So, it is a hit. Then come to the next one, it is 3. So, here I have to look into the memory, 3 is not available. So, I have to go for replacement. So, 7, 0, 1, 2 are available. So, now I have to replace 7 because it is, that is I have to look into the future. So, I have to replace, I have to place actually 3. So, after this one there is no 7 in the reference string. So, what is the meaning of that? There is no need for referring 7 again. So, I will replace 7 by 3. So, now it is a page fault. Then the next one is 0, 0 is available, it is a hit. Then again it is 4, so I am looking for 4, it is not there. So, I have to go for a page replacement. So, after this 4, I do not have any reference for 1. So, 1 can be replaced. So, 1 is replaced by 4. Again it is going to be a page fault. Then the next one is 2, 2 is available, it is a hit. Then 3, 3 is available, it is a hit. 0 is a hit. Then 3, 2, 3. All these cases we have hit, there is no page fault. Now, let us count the number of page fault, 1, 2, 3, 4, 5, 6. So, the number of page fault, it is 6. It is in the case of optimal page replacement algorithm. The next one is LRU, that is least recently used. So, in the previous case, we are looking for the future. So, in the reference string, we look for the page which will be coming into the request. But many times it is not possible to predict the number of the page which will be coming into the reference string. So, here in the case of least recently used, what we are going to do? We are going to consider the history, that is the page will be replaced which is least recently used. That is the page which is not at all being used for long time. So, we look at the previous history and based on that we will go for the replacement. So, as usual 7, 0, 1, 2 they will be put into the frames 1, 2, 3, 4. So, all these are page fault. Then when we come to the next one 0, it is available, so it is a hit. Then when it is 3, then we have to look here, it is not there. So, I have to go for the page replacement. So, here I am looking. So, here 0 is referenced recently and 2 is referenced recently, 1 is also referenced recently. So, only 7 it is not at all referenced for a long time. So, I have to replace 7 by 3. So, now it is a page fault. Then come to the next one, it is 0, 0 is there, it is a hit. Then 4 is not available, so I have to replace one page. So here just I am referring the history. So 3 is a reference here, 0 is a reference here, and 1 is there and 2 is there. So 1 is the page which has not been used for long time. So I have to replace the page 1 with 4. That is 1 is least recently used. Then comes 2. So 2 is there, it is a hit. 3 is there, it is a hit. 0 is there, it is a hit. 3, 2, 3, all these are available in the memory. So again all these are hits. Then let us find the number of page fault. So 1, 2, 3, 4, 5, 6. So totally 6 page faults are there. That is in the case of LRU. So from the table we can understand FIFO, it is very simple to use, but regarding the number of page fault, we are going to have many page fault. So the performance of FIFO, it is not going to be good. And if I go for more frames, then page fault, number of page fault is reduced. That's what we have seen from the table, and usually LRU adapts better than FIFO in dynamic reference patterns. Optimal algorithm, actually only it is a theoretical benchmark. Here the reason is never we can predict the future. So in future what will be the request, what are the pages that will be requested, so that is very difficult to predict. So optimal replacement is a theoretical benchmark, so it cannot be mostly used. In most of the cases we are using this LRU. Thank you.